Grateful day to everyone. Myself Sobana, Assistant Professor in the Department of IT at VSB Engineering College, Karur. It's my immense pleasure to share something about artificial intelligence and machine learning. In this subject, there are 5 courses, and now we are going to learn among one of that. So this is course 1, problem solving, and these are the topics in this course. The objective of this course is the students can easily able to study about the uninformed and heuristic search techniques. There are 12 program outcomes. So the program outcome 1 is engineering knowledge, 2 is problem analysis, 3 is design and development of solution, PO4 is conduct investigation of complex problems, PO5 is modern tools usage, PO6 the engineer and society, PO7 the environment and sustainability, PO8 ethics, PO9 individual and teamwork, PO10 communication, PO11 project management and finance. Finally, the PO12 is lifelong learning. So there are 12 program outcomes. Among these 12 program outcomes, few of the program outcomes are matches with these courses. They are PO1, which is engineering knowledge, and PO2, which is program analysis, PO3, which is design and development of solutions, PO4, which is conduct investigations of complex problems, PO5, which is modern tool usage, PO6, the engineer and society, PO8, which is ethics, PO12 is lifelong learning. So these are the POs matches with this course. These are the contents today we are go through, and the topics are introduction of artificial intelligence and machine learning, the history of AI ML applications, and problem solvings. So here we go. Artificial intelligence and machine learning. So first we will go through about artificial intelligence and then machine learning. So the first, artificial intelligence. It is a field of computer science focused on creating machines that can mimic like human intelligence, enabling them to learn, solve problems, understand language to perform the tasks that typically require human thinking. The virtual assistants like Siri, Alexa, then the recommendation systems like Netflix, the self-driving cars are developed nowadays. The science of making machines smart, enabling them to perform the task requiring human-like intelligence, the reasoning, learning, perceptions, etc. The board encompassing any system that act intelligently, including non-learning methods like expert systems. So, simulate the human cognitions, the functions of robots, and a subset of AI where algorithms learn from data to identify the patterns and make decisions or predictions. So the goal is they enable machines to learn and improve from experience. And then machine learning. Machine learning allows the computer to learn and make decisions. It is used in various applications like image recognition and speech processing, etc. It involves the feeding the data and algorithms to identify and to make the predictions on need. Artificial intelligence. The artificial intelligence is a technology enabling computers to perform tasks needing human intelligence like learning, reasoning, problem solving, perceptions, and language understanding by processing the data to recognize the patterns, make decisions, and improve autonomously. So the AI is a branch of computer science that focus on creating machines or software that can think, learn, and make decisions like the humans. AI allows computer to do smart works that normally need human intelligence. The AI is growing rapidly and will play a major role in technologies, education, and industries in the future. Machine learning. Machine learning is a branch of artificial intelligence that trains computer system to learn from data, finds patterns, and make decisions or predictions without being explicitly programmed for every task, improving performance as they process more information. It uses algorithm to build model from data, enabling applications like personalized recommendations, fraud detection, and autonomous vehicles. Key type include supervised learning, unsupervised learning, and reinforcement learning, etc. A subset of AI that uses algorithms and statistically models to analyze the data, learn patterns, and make predictions. So ML is a core to improve without explicit programming form the foundation of modern AI applications like recommendation engines and self-drivings. AI applications. So the artificial intelligence applications are vast, powering everyday tools like virtual assistants, which is Siri and Alexa, search engines, and recommendation systems like Netflix, Amazon, while also revolutions industries through autonomous vehicles, healthcare, diagnosis, financial fraud detection, personalized marketing, smart cities, drug discovery, and enhancing cybersecurity by all analyzing the data, recognizing pattern, and automatic complex decision for better efficiency and insights. So the AI is also applicable in banking, transport, education, agriculture, etc. So nowadays the AI is performing in each and every field. History of AI. In 1950, Alan Turing, knowing what the final outcome of his research would be, published the idea of Turing test. The Turing test was a simple evolution of computer intelligence designed to see if a machine could reasonably fool a human into thinking that the machine to possessed human intelligence. In the paper in which Turing posted his imitation game, he also made a major defense for a radical idea. Machine can think. Turing asked his audience to redefine the idea of what thinking. Somewhat nebulous concept truly meant the symbolic AI approach to recreate the way the human mind works. Part is using the symbolic school of AI to recreate human-like system of logical process and within the computer languages. The computing approach to machine intelligence was known as the connections approach, which attempt instead to more closely emulate the working of the human brain. The connectionist approach to create artificial neural networks that behave similarly to the networks of neurons in the brain. So, the symbolic approach to AI dominated from the 1950s until the 1990s. But the recent development in 21st century have allowed for connectionist idea to gain new traction. In 1956, an AI workshop was held at Dartmouth College, and the field of artificial intelligence was officially founded as an academic discipline. Computers from the Dartmouth workshop were shown to be able to solve algebra, word problems, learn English, play checkers, and move results that were stunning to the modern audience of the time. Press coverage of the workshop created a media fancy, and by the 1960s, Defense Department and labs all over the world had established research programs into artificial intelligence. Many scientists in the field believed that the creation of full-blown artificial intelligence machine was right under the corner. Unfortunately, by the mid 1970s, many technologies constraints and limitations severely hindered progress. In 1974, the US and British government eliminated AI project funding due to budget consideration. So this would later be known as the first AI winter. In 1980s, computer technologies advanced significantly. One area of advancement was in export systems. So the export systems are computer programs designed to mimic the thought, progress, logic and decision making of real human experts. Instead of conventional procedural code, the expert system employ if then rules to reason through existing knowledge in order to solve the problems. Implementing this expert system was a widespread commercial success that the dying field of AI research and development. So by the mid of 80s, AI technology had become a billion-dollar industry. So the Japanese government efforts to produce an $850 million approach making AI supercomputers revived global government funding of AI research. But various failures lead to the second longer, the AI winter. So in the mid of 90s is considered as the second AI winter. Evolution of the AI. So the AI and the robotics research of the late 80s expressed criticisms of the dominant symbolic approach to AI development, advancement in human neuroscience and cognitive psychologists reviewed interest in the connectionist approach to AI. This shift in focus led to the creation of many important soft computing tools such as neural networking, physiologic system and evolutionary algorithms. By the late 1990s, AI was once again the belle of the technological ball, and by the millennium, systems produced by AI research were widely used in computing. Improvement in computing speed and the cost coupled with the explosion of big data allows for incredible advancement in machine learning. Computers could now intake and process massive data sets, and by 2015 Google had more than 2,700 AI projects in development. And that brings us today where the history of AI technologies enabled by the cloud computing, deep learning and more big data continues to be written while the initial goal of a fully intelligent machine has yet to be met. The field of AI research has had incredible for researching the impacts of much of society. So in 2017, survey report that 1 in 5 companies had incorporated AI process in some aspects of their business, and in the period from 2015 to 2019 published AI research increased by 50%. We live in an AI future many said humanity could never see. So in 2011, introduction of AI virtual assistants such as Siri, and in 2016, the Sobia, a social humanoid robot, was activated. In 2018, Google released BET, a model for natural language processing that improves contextually understanding of text. And in 2020 to 24, the advancement in autonomous AI, vehicle simulation systems, and the general purpose of AI agents. History of machine learning. After seeing the history of artificial intelligence, now we are going to know about the history of machine learning. So machine learning is a field of study in artificial intelligence concerned with the development and study of statistical algorithms that can learn from data and generalize to unseen data and thus performs tasks without explicit instructions. Within a subdiscipline in machine learning, advance in the field of deep learning have allowed neural networks of class of statistical algorithms to surpass many previous machine learning approaches in performance. Machine learning finds applications in many fields including natural languages processing, computer vision, speech recognition, email filtering, agriculture and medicines. The applications of machine learning to business problem is known as predictive analytics. So the statistics and mathematical optimizations method compress the foundation of machine learning. The data mining is a related field of study focusing on exploratory data analysis through unsupervised learning. The Deep Blue. In 1997, IBM's Deep Blue defeated world chess champion Garry Kasparov, a landmark achievement for game AI. Everyday integration is the AI became embedded in consumer technology with the release of the Rombo in 2002 and the Apple's Siri in 2011 and IBM Watson's 2011. The question answering system defeated champions on the quiz show Jeopardy. History of machine learning traced from early neural network models 1940s and the coin of the terms by Arthur Samways in 1959 to key milestones like Alan Turing's test in 1950 and the Samways Seekers program in 1952 and the first neural network in Perceptron 1958 also. After yearly existence, AI winter slowly progressed, but the 1990s saw a shift to data-driven approach with a major breakthrough like Deep Blue beating the Caspro in 1997. This 21st century brought exponential growth due to increased the computing power and data, fueling the deep learning revolution with the success like Apple and large language models like ChatGPT, which is done in 2022. Now we are going to see about the problem solving agents and then search algorithm in artificial intelligence. So the problem solving agents are an essential part of artificial intelligence designed to tackle complex challenges and achieve specific goals in dynamic environments. So these agents are work by defining the problems, analyzing the problems and then identify the solution, finally choosing the solution in that. So in this, searching is the most commonly used technique of problem solving in artificial intelligence. The searching algorithms help us to search for solution for particular problems. So in searching algorithm in artificial intelligence are systematic methods used by AI agents to navigate and explore the problem spaces from an initial state to a desired goal state. They form the backbone of problem solving and decision making in various AI applications such as pathfinding, game playing, and scheduling. So the search algorithms are fundamental to artificial intelligence to find optimal or feasible solution by exploring a range of possibilities within a defined search space. These algorithms are broadly categorized into uninformed search and informed search, depending on whether they use domain-specific knowledge to guide their search. So the types of search algorithm in AI is uninformed search and informed search. So in uninformed search algorithm, the algorithms explore the search space systematically without additional information about the goal's location. So the breadth first search explores level by level using a queue and grants the shortest path in unweighted graphs. So depth first search, it explores along branches as deep as possible using a stack. It is memory efficient but doesn't grant the shortest or optimal path. And then uniform cost search. It expands based on the lowest cumulative path cost using a priority queue and is optimal for weighted graphs with non-negative cost. Iterative deepening depth first search. It combines the depth first search space efficiency with the breadth first search completeness and optimality by repeatedly running DFS with increasing the depth limits. Bidirectional search reduces the search space by running simultaneously searches from both the start and goal status. Informed search, so in informed search, these algorithms use heuristic function to guide the search more efficiently towards a solution. Greedy best first search expands the node appearing closest to the global based on the heuristic value. It is a fast but may not find the optimal solution. So a local search that moves towards immediate improvement to reach a local optimum but can get stuck, which is called hill climbing, and then stimulated an extension of hill climbing that can escape local optima by occasionally accepting worst solution. So the application of search algorithm in AI, search algorithm are applied in various AI application. Pathfinding and navigation is used in GPS, robotics and games for finding routes and avoiding obstacles, and puzzle solving. Problems like the 8 puzzles and Sudoku use such algorithms. the game playing. Adversable search algorithms like Minimax and Alpha Beta are used in games like chess. So planning and scheduling used in logistic and automation for creating efficient plans and resource allocations. So hereby we learned about the basics of the artificial intelligence, machine learning, and the basis of problem solving agents and search algorithm. For this, I refer the book Artificial Intelligence and Machine Learning, the Modern Approach of the fourth edition written by Stuart Russell and Peter Norway. Here I posted three questions and the person who listened in the above PPTs, just drop your answers in the comment box. Thank you for watching and we will see in the upcoming videos with lot of information about the AI/ML and the problem solving agents. Thank you. Have a good day.